The lesson outcome for this video is I can use power rules, the 6th and 7th rule. All right, so once again, I just want to remind you that we have already completed these 5 rules now. All right, product of powers, that is going to be an example of that really quick. X to the 3rd times x to the 4th will be x to the 7th. We add the exponents. A power of a power, if I have a power that is raised to another power, this will be x to the 12th. The power of a product, if I have a product, let's say x times y being raised to the 4th, then everything in the parentheses, the factor of x gets raised to the 4th and the factor of y gets raised to the 4th. Quotient of powers. This is where if we have x to the 3rd over x to the 4th, the way I work with this one to process this is I ask you, if you were to expand x to the 3rd and x to the 4th, where would you have more x's remaining? And the answer in this case would be the denominator. So if I have the denominator has 4 x to the 4th, and this is x to the 3rd, we have one more x in the denominator than in the numerator. So we have x to the 1st down here, and we fill this in with a 1. Which means we could just write this as 1 over x. And then power of a quotient. So this is where if I have a quotient or a division situation and it's raised to a power, I will again give that power to everything in the parentheses. So let's go ahead and learn our last 2 power rules, the 0 power rule and the negative power rule. All right, so the zero exponent rule here is simply that, and this one's really simple, anything raised to the 0 power is the number 1. Okay? Not x to the 1st, not 1x, just the number 1. So if I've got m to the 0, it is 1. If I have a times b to the 0, well, anything raised to the 0 power is 1. The one thing you have to be careful for here is what if I have 4x to the 0 and there's no parentheses? Be careful here, because what this is saying is that x is being raised to the 0 power, but the 4 right here is actually raised to the 1st. It's just not written in there. So this one would actually be 4 times x to the 0, and x to the 0 is 1, so it would be 4 times 1, or just 4. Now the last power rule we are going to learn is the negative exponent rule. All right? So I'm going to show you a couple of examples of this. So here is the phrase that I use when talking about the negative exponents. I write, when you have a negative exponent, you move it and make the power positive. Okay? You move it and make the power positive. So what I mean by that is I'm going to start by writing a fraction bar whenever I have a negative exponent. So right now x to the negative 3 does have a denominator. That denominator is 1. So what I have to do is say, all right, I have a variable x, a base of x, with a negative exponent. And we don't like to be negative. Let's put it that way, right? So if I have x to the negative 3, I need to move it and I need to make the power positive. And what I mean by move it is move it to the opposite side of the fraction bar. So right now it's in the numerator, so I need to move it to the denominator, and I need to make the power positive. So instead of negative 3, I will have positive 3. Now, this 1 right here is still right here in front of the x, and we don't have to write it in, though we could. But what do we have to fill in up here? Well, remember, there's always a 1 in front of every variable that doesn't have a coefficient written in. So that 1 right there is just right here in our answer. All right, so let's look at this other one right here. Again, I'm going to leave my fraction bar. I have x to the 2nd power already. Now, that doesn't have a negative exponent. See this? This 2 is positive. So that's going to stay exactly where it started. So that's going to stay there. But in the denominator, we have x to the negative 3. Okay? So it has a negative exponent. So we need to move it and make the power positive. Okay, the exponent positive. So we're going to move this, x to the negative 3, to the numerator, because right now it's in the denominator. We're going to move it to the numerator, and we're going to make this negative 3 right here positive. All right? Again, there's always like a 1 right out in front of here, so there's a 1 right here, which we wouldn't have to write. And if we simplify this a little further, we have x squared times x to the third. What we've got here is the first rule we learned, the product of powers rule. So we add the exponents. We get x to the fifth over 1. And remember, x to the fifth over 1 is just x to the fifth. So let's just try one other quick example of this, and then we will practice it a lot in class as well. Okay. So it looks kind of complex, but it's actually pretty straightforward. We're just going to start with every single factor separately. This 3 right here, does it have a negative exponent? No, so we leave it. This x to the negative 2, does it have a negative exponent? Yes, so we move it to the other side of the fraction, and we make the power positive 2. This y, does it have a negative exponent? No, so we leave it. This negative 4, this will throw some of you off. Does it have a negative exponent? No. It is a negative number, but that doesn't matter. Negative numbers stay. I like to leave it in the front. Now, x, does this have a negative exponent? No, so we leave it. Y, does y have a negative exponent? No, so we leave it. Z to the negative fifth, does it have a negative exponent? Yes, so we move it, and we make the power positive. Now, we have to simplify our answer using rules we've learned in other lessons. 3 and negative 4 cannot be simplified as our coefficients. We can leave those where they are. Notice we have a y up here and a y down there. Where do I have more y's? Well, neither place. The y's actually cancel each other out. All right, z to the fifth. Z to the fifth is in the numerator. There's no other bases of z, so it will stay where it is, z to the fifth. And in the denominator, we still have this right here. We have an x squared and an x to the first. So they have the same base. So we add their exponents, and we will have x to the third. This is our final answer.